Hey, Chan Physics, Mr. Block. Just trying to get last kind of things done before I leave on Friday. So, if you're looking at this video, you're trying to study for the Unit 3 test on Monday. So, I'm going to do a couple of things real quick, and then I'm going to go through the study guide. But before I do, remember that we're focusing on this idea of learning to reason out question as opposed to try to memorize. And so, if that's your struggle right now in physics, we're going to try to remember that we try to remember ideas, and then when we get the questions, we reason out the answer. So the two things that we definitely need to know, first of all, is we need to know what the atom looks like. And so when we look at the atom, we've got the positive and negative charges right in the middle, the electrons way outside. And so what this tells you is when you know what the atom looks like is that the electrons can be moved. And that's what we spent the whole time playing all those games of with the rabbit's furs and the tape and anything else where we were moving electrons, was to show you that those electrons can move, but these protons and neutrons cannot. And so in my class, we joke that if you accidentally tell me that the protons move, I'm going to come to your house and I'm going to make sure that you understand that that cannot happen. Okay, so please, please, please don't say protons or neutrons move. Only electrons move. Okay, and then the other thing that we need to know is how electricity works. And so if we look at this picture here, is a really just a really good example of how we need to picture electricity. Electrons are moving around the circuit, and when they get to the back of the battery right here, remember current goes from positive to negative. So when they get to the back of the battery, they are dead tired. You see the cups are empty. And so they have no energy. And when they come through the battery, they move up and they are given a bunch of energy. So now they have this energy. When they come out of the positive, if this is a 1.5 volt battery, then now they have 1.5 volts of energy. If it has a 9 volt battery, then this is 9 volts of energy. And now the electrons are ready to go. And so they come across here and they get to some place where they're going to use up that energy. So they go to the bulb and they have to squeeze their way through this filament. And doing that, they give off heat, they give off light, they lose this energy, and now they come back empty handed and come through this again. And so that's how we can always look at these kind of different circuits. So I'm just trying to find a quick circuit here. So here's a circuit, a real life circuit, and another one. So remember, the current goes from positive to negative, and so they come out of the battery. It has electricity, it has voltage, it has energy, and it's going to lose that energy through the bulb and come back dead tired. And we can always think about it that way. Okay. All right. So let me turn the camera on and let's get to the study guide. So the study guide answers are here. I've already done them all, so we won't be doing any work in this review. We're just going to go over the answers. Of course, opposites attract right here. So opposites attract, and like charges will repel. Define static electricity. So just like I was just talking about, right? Electrons that have accumulated on one object over another. So one object gives up the electrons, one object takes the electrons. This one's negative, this one's positive, right? And we can always say that the electron's moving, but that's it, right? We can't become charged because we're moving protons. Right? How is charging by conduction or contact different? Well, remember, contact was we had the the different things that we would rub against the rabbit fur. The rabbit fur would give the electrons to that thing, so we had to have some sort of friction, and so that's contact. Induction would be that we grab something that's already charged, like our PVC pipe, and we bring it up to another object. All the electrons are evenly spaced here, but then when that pipe comes nearby, all of these electrons move over to the other side, making half positive, half negative. And so now our ball would be half positive. And that's induction. So you can force the electrons to move away because they are so afraid of the other electrons, they're being repelled. All right. A neutral plastic strip is rubbed with cotton and acquires a positive charge. Which of the following statements? So we have to look for the ones where I think I've got the wrong answer here. It does not lose neutrons. it lost some electrons to the cotton. So this is C, right? So we don't lose neutrons, we only move electrons, okay? If you're worried about these ideas right here, 6 and 7, where we talk about the strength of the electric field, make sure you know the questions that are going on back here. But the reality is that I don't know if we're going to test this very heavily, this idea of the electric field being the force divided by the charge. But you can see there's an answer here for this one, and I say don't worry about something like this one, okay? How are electric field lines drawn? So remember, just like our current goes from positive to negative, so does our electric fields. So the outward from the positive charge and inward to the negative charge is the right answer there. Okay. Question 9. All right. What does the spacing? So the closer those lines are, so like here we see these closer lines. So this must be a bigger charge because it creates more fields. And then the fact that it's not coming over here, this must, with all of those lines aren't as spaced as tightly. So this must be a weaker charge. Define the charges in objects C and D. So C, we see the lines coming out, so they must be the positive ones. And then the numbers are going into, or D is positive and C is negative, right? So from positive to negative. And then we must know that D is greater because it has more lines coming out of it. All right, the next couple questions are Coulomb's law. So it's just classic Coulomb's law. Either we're going to have something change and just ask you how much it's going to change, or we'll actually have you put that number into your calculator. So the first ones are these ones where they're going to change something. So the first one that says if they're going to decrease the distance by a factor of 3. So if we decrease the distance by a factor of 3, they're going to come closer together. We know just conceptually that must mean that the charge or the force between them is going to get much stronger, right? And so when we look at that idea, the first thing is we should gut check ourselves and say, okay, wait, if they get closer, then our number must be going up. Only figure it out is how much, right? So remember what we do is we write down the equation. So here's just Coulomb's law by itself. And then we rewrite the equation, this time with what they told us happened. So we're going to reduce the distance by 1/3. Right? Then we simplify. So we didn't change K, we didn't change Q1, we didn't change Q2. But we did cut the radius by 3. And so we have to square that. So when we square R, it becomes R squared. When we square 3, it becomes 9. And so when we divide by a fraction, remember we can then flip the 9 up to the top. And so this becomes 9 times as much, right? And that makes our gut right? That it should be going up by 9 times, all right? And so that's the answer for number 12. 13, just plugging in the numbers. Remember to use the EE button. A lot of kids I'm seeing are putting the number then times E. No, it's just the number EE and then the -3 or whatever that number is right there. So these are just plugging into the number. Here, this is a little bit difficult because they're asking us to find R. So R squared right here. So how do we find that? Well, we multiply by R squared on both sides. And then we divide by 420. And then we take the square root. So we end up with R is equal to this times this times this, divided by 420, and we take the square root of the whole thing. And then we get 0.17. All right, on to page 2. Boom. So we'll be pretty fast here. This one, they're asking us to find this Q1 or Q2. It doesn't matter which one it is, okay? And so I put the equation down. I put in the numbers as they told us. How do I solve for this? Well, I must have to multiply by this on both sides. So the whole R squared must be multiplied on both sides. So it's this times this, divided by this, divided by that. It will get us Q2. And so this is the answer right here. All right. Particularly important question. So if you've gotten to this part right here and you're studying for blocks test, series and parallel, what are the differences? So series, there's one loop. Parallel, there's multiple loops. Series, there's one current throughout the entire circuit, and in parallel, the currents are different, right? And so we can see that pretty quickly, right? If there's one current here in the series, there can only be one current. There's only one place for that water or the electrons to go. But in parallel, well, that current comes out of the battery and it's going to split. Some of it's going to go this way, some of it's going to go this way. Then it's going to split again, some down here, over here. And so the currents are different. And then the last thing in a series, the voltage of the battery equals the voltage drops. We gain the voltage here, we lose it, we lose it, we lose it, right? And then we have to come back down here to 0. So that's how the beginning of this tape, we talked about how when we get through the battery, we gain voltage, and then we have to lose it all in the circuit. Well, what's the counterpart for parallel? The voltage of the battery equals the voltage drop in each loop. So think about it this way, gain 4.5 volts here, we're going to have to lose 4.5 volts here to get back to 0. Right? We're also going to gain 4.5 volts here, but our electron decides to choose this path. It's going to lose all 4.5 here. Right? And then over here, gain 4.5, it's going to lose 4.5 here. Whereas here, with our battery being 4.5, and then all of our resistors being 9, this one it's going to gain 4.5. It's going to lose 1.5 here, 1.5 here, 1.5 here to get down to 0. So all three of these add up to 4.5, whereas in parallel, all of these are drops are 4.5. Okay, and we'll talk more about that when we focus more on Ohm's law in 2 units, I think. Okay, the last one of these combination circuits that we didn't spend a lot of time, but remember what you do in a combination circuit is always take the battery and go as far away from the battery and start looking for things that you can combine, either in parallel or in series. And so once we go as far away from the battery as we can here, we see that these two are in parallel. We know that they're in parallel because the current has to split and decide which one to go to. So that's parallel. So we can combine these two in parallel with the parallel equation. 1 over Rp equals 1 over 6 plus 1 over 6. We do that equation, we get 3. Okay, so these two resistors have an equivalent resistance of 3. So what do? Well, we can redraw. And so we didn't change this one, so that stays there. We didn't change this one, so that stays there. We didn't change this one, so that stays there. But we combine these two, so we redraw it as 1 3 ohm resistor. Okay, now we got a brand new circuit to play with, and we say to ourselves, okay, well, these two look like they're in series, right? Because this current goes through this, and it's got to go through that without splitting. And the same thing here. So we can combine these two and combine these two. So RS equals 6 plus 2 or 8. RS equals 5 plus 3 or 8. So now we've got the ability to redraw. So we got the battery the same, but these two have become 8. These two have become 8. And so now we've got a simple parallel circuit. Now we can use our parallel equation to combine these last two. Okay, 1 over Rp equals 2 over 8, or Rp equals 4. That's how we do those equations. So it's just a step-by-step, go away from the battery, start combining things, redraw, look again, combine some things, redraw, combine some things, and get the answer. Okay, and so the last one is done the same way. We've got 2 sets of things that are in series, so we put those together, we get 8. We redraw, so these 4 resistors become these 2 resistors. Now we see that they're in parallel, so we combine them in parallel. Once we combine them in parallel, well, then we can redraw again, and then we can put that together. Okay, so hopefully that is helpful to you guys. I got to go back and scan my key because I had that one wrong, but I appreciate all that you guys are doing if you're studying this weekend for this test. So I hope all is well, and I'll talk to you guys on Monday.